Okay, so we're going to do a lesson now on measuring angles and identifying them. All right, we're going to start with a lot of definitions. So take notes in this. We're going to work a lot with definitions in class as well, but take some notes in your notebook for this. And some of these you hopefully already know. Okay, so a ray is a part of a line with exactly one endpoint. I really probably should have started with line, but anyway, we'll get through this. So a ray is just part of a line, and there's an example. It's just the part that, like almost half of a line, you can think of it. It has an endpoint, and then it goes on infinitely in one direction. We call that ray AB, okay? A line is a series of points that extends without end in both directions. Okay, so it's just, you know what a line is, you've been working with it all your life, but that's like a more technical definition. And usually lines are named with with one lowercase letter, like L or P or Q or something. So that's line L. All right, a line segment is part of a line with two endpoints. So it's kind of like a ray, but instead of going on forever in one direction, it actually ends. And so there would be your line segment. We call that segment MN. Okay? All right, an angle is a figure formed by two rays. So when you put two rays together, they share a common endpoint. Okay, and the common endpoint here would be A. Okay, that's like one ray, and that's another ray. And they have to happen to end all on that, they happen to meet at that one endpoint. Okay, and we can call this either, not angle ABC, you'd call this angle BAC, okay, BAC, or you could call it angle CAB, okay, as long as the A is in the middle. Or you could also just call it angle A, okay? But if you had another angle there, like if you had something extending there and this was like D, you wouldn't, if you said angle A, you wouldn't know which angle you meant. So you want to be sure. If it's only one angle possible there that we're used to, I know there's two angles, some of you are thinking, but there's one angle that we think of most of the time. That would be that angle. We can call it angle A. Anyway, we'll get into more of this. All right, now a vertex is an actual point. Okay, the vertex is the point where two or more lines or sides or segments or rays intersect. Okay, it's the point where they intersect. So in this case, A would be the vertex. A is a vertex of this angle. A is where those two rays intersect. Okay. All right, now a couple things you're going to need to know about in class is what a protractor is. A protractor is basically one of these things. I tried to draw it, but it kind of looks like this. It's like half a circle, and it has a lot of lines and numbers on it. And that's a tool for measuring angles. Another one is a compass. It's a geometric tool used to draw circles and arcs, and it looks kind of like that. I don't have an example of it here for you, but we'll be using that later on in class. Okay, it has a pencil on one side, and you make this thing stable, and then you draw with the pencil. Okay, more definitions. Try to separate them to kind of give you some division so it'll be easier to think about. Okay, these are all the types of angles that we have. First type of angle is an acute angle. And that measures less than 90 degrees. And it's easy to remember this because it's cute. It's little. It's cute. So acute would be one way to think about that. And that's an example of an acute angle. A right angle, you know this, measures 90 degrees. And usually it's indicated by that box. If there's a box there, that means it's 90 degrees. It's a right angle. Obtuse angle measures more than 90 degrees but less than 180. Okay? Straight angle is an angle that measures exactly 180. And you can say, well, that's a line. You're right. It is a line. It's also can be called a straight angle. That measure, that angle from here to there is 180 degrees. Okay? Okay, now we have angle pairs. Complementary angles are two angles whose measures total 90 degrees. So they would fit inside of one of these things that has a box. Okay, these are two. This is one angle, angle 1, angle 2. Okay, those are two angles. To be a pair of angles, you have to have two angles. This is just one angle, the definition of one angle. Now we're getting into angles that are together and what happens. Now these don't have to be written together. You could have this and you could have this. That's angle 1, angle 2. And if this is, say, 30 and this is 60, we could still say that they're complementary because they add up to 90 degrees. They don't have to be actually next to each other physically. Okay, supplementary angles are two angles whose measures total 180. But again, it could be the same thing. They could be all together like this. They could be together, share a common side, a common ray, or they could be separately drawn. But as long as their sum is 180, they're supplementary. Vertical angles is probably something new. These are angles formed when two lines intersect. When two lines intersect, you got many angles, but obviously you see four. All right, what the vertical angles are the ones that are opposite each other, and they actually have equal measures. So the vertical angles here would be angle 1 and angle 2 are vertical, and angle 3 and angle 4 are vertical angles. Okay, so we'll keep that in mind, and we'll be working with that a little bit more too. Okay. I think, now we take a little break. No, we don't. Did we? Yes, we did. We take a little break, and I'll just tell you how to use a protractor to measure. Some of you may already know this. First of all, you always want to estimate. You want to say, okay, well here I'll make this angle A and angle B. Well, angle A I know looks like it's an acute angle. It looks like it's less than 90 degrees. So I'm saying maybe about 60 degrees. And as you get to measure these and see what angles look like, you can probably get pretty close to the measurement. But I know if I get something like 180 or 120, something's wrong, because I know it has to be less than 90 degrees. Angle B, on the other hand, looks like more than 90 degrees. Looks like I can fit a little right angle in there, so I know it's more than 90 degrees. So I'm going to say 115. I don't know, just more than 90, but not quite that much more than 90. Okay, then what you want to do is place the protractor actually on the ray, on the ray of the angle. You put there's a long line at the bottom of the protractor, and then you have a dot. So you put that long line on there, and you make sure the center circle of the protractor is right as much as you can on the vertex of that angle. And then you see where it extends, where the second ray extends. And I have two choices. Here I have, it's about 120 or 60. Well, that's where my estimation comes in handy, because I know it can't be 120. So actually I got this pretty right. It looks like it's about 60 degrees on the protractor. Okay? So that's what you basically do. And let me do it again for this one now. For this one, I lay the bottom of this line that's on the bottom of the protractor, line up on one of the rays as long as that circle on the protractor is right on the vertex. And this extends, and this is it's between 50 and 60, or it's between 130 and 120. Well, I know it can't be between 50 and 60 because I know it's got to be more than 90 degrees. So it's between 130 and 120. It's about 2 or 3 away from 130, so it's about 128 or 127. So that's how you would kind of count it. And we'll do more of this in class. You can see individually if you don't quite get this. All right, so my angle measure here is about 128, which wasn't too bad. It was a little bit off there. All right. And sometimes you'll need to count those little lines and subtract or add depending upon what it's between. I knew it wouldn't be 131 or 32 because the next where it was headed was near 120, so it would be less than 130. You'll see that when you get your own. Okay, this is the last one for this video. And a couple more definitions about triangles. And I sort of separated them into two, which I think will help you memorize it better in case you don't know these. Some triangles are named for their angles, and some are named for their sides. Okay? Acute triangle is all three angles are acute. They're all less than 90 degrees. Obtuse angle, well, they can't all be obtuse, because if you're going to try to draw a triangle with all obtuse angles, you never close in to get to the other side. You just keep going obtuse, obtuse, and it would never work out. So it has to be only one of them. Only one angle is obtuse, and that's why. Or it wouldn't be a triangle. A right triangle has one right angle. Okay, so those are the angles that we have. Named for their angles. So these are ones that are named for their sides. If you have an isosceles triangle, that means two sides are congruent. Two sides, not all three, just two. Equilateral is all three. All three sides are congruent. And a scalene means no sides are congruent. You've probably heard of some of this before. All right, so I thought we'd play a little matching game and see if you can match these up. And some of these will have two names, okay? All right, this one obviously is your right triangle. Okay, that's your right. But it also looks like it's scalene because it didn't look like any of those sides are the same. So I'm going to put R and S, right and scalene. This one, I think this looks like it's more than, I think that's obtuse. Well, let's see. I'm going to say it's obtuse. We won't know until we actually measure. But we'll say obtuse and scalene because it doesn't look like any of the sides are the same either. This one looks like it's all acute. This could be a right angle, but because it's not marked, it probably isn't one. So I'm just going to say acute. And it looks like it might be isosceles. It doesn't say, but so you could either say scalene, or you could, if you think it's isosceles, that'd be fine. Again, you have to measure it to make sure. Now this one is already marked, and the reason why I marked it so you can know that when it's marked like that, that means these two sides are the same. Or sometimes you'll see two markings. If that one has the same marking as that, then that means they're the same. So this is definitely isosceles, and it looks like it's acute. It looks like they're all less than 90 degrees. This one obviously looks obtuse. This is obtuse angle, so this is obtuse and probably scalene. This one is equilateral, right, because they're all three sides are the same, and it looks like it's also acute. This one looks scalene and perhaps acute. We're not sure if, yeah, that looks like it's less than 90, and those are both less than 90. So it looks like it's scalene and acute. Okay, hope this helps. We'll do more of this practice in class.